So welcome back in my next class of the operating system. So in continuation, this is lecture number 3. Now here we will discuss that how do processes share the CPU. Okay. So about the various functions, characteristics of the operating system. So far we have already discussed in our preceding lectures, lecture 1 and lecture 2. So far we will continue in the similar fashion. So how do processes share the CPU? So first we will concentrate over how will we define the process. Okay, so if any program is running and under execution, so then that program is called the active process, or we can say process. Okay, before that, whenever we are going to write any program on the screen of the system, then we can say that it is a passive element. Okay, so there are two things, passive element or the active element. Now as it will go under the running condition, or we can say under the execution, then we can call it as the process. Okay, so how the process share the CPU? So under execution, or we can say under the running condition, the process has full connectivity with the central processing unit. Okay, it will go in the main memory, and after that it has in full interaction with the central processing unit, because every processing will be done inside the central processing unit. Now we can say the OS maintains a per process. Okay, so the operating system, as we will write the program or we will do any task, any work, then it will go one by one to the central processing unit. So it will maintain the per process system. Okay, so each program or the task or the entity will go toward the central processing unit, and this facility or the interaction will be provided by the operating system. So the process control block, we can say, so PCB. I think you have already heard this name. Okay, process control block. Here we will maintain the record of all the processes in the PCB, process control block. And like the register, every process will reside here, and here we will do the nomenclature of that particular process. Okay, so it will reside in the PCB, process control block, that is called, so which stores state for non-running processes. Okay, so it also stores the state for non-running process. So as we are we are doing the preparation for a particular program, and we are thinking that we are going to run that program, or we are sending that program to the CPU for the execution purpose, then as we will click, then before that there are number of states. So for that particular states, it will maintain inside the PCB, process control block. So which stores state for non-running process. It also has the record for the non-running processes. Now on a context switch, so what is the function of that? Save state of the old process. Okay, so context switch, it has the record or save the state of the old process. So there are a number of states for a process. Okay, so I will also tell about the different states for the process. So it is we cannot say that this is only the state, just we are clicking on the compilation button or running button or the execution button. Beside this, there are a number of processes. Okay, which we can say will do that the initialization of any process. Okay, how we will initialize, and where we will store the initial address of that particular process, and how will we proceed to the next state for a particular process. Then all type of states will maintain uh, in somewhere registers. Okay, so it save state of the old process, restore state of the new process. So it will also restore state of the new process. Suppose if there is a new process, and then how it will maintain the record That is called the restoration or the restore state of the new process. Now you can see here the interaction with the CPU. Central CPU is central processing unit, and how it has the connectivity with the old PCB or the new PCB. Okay, PCB means process control block. So for the new process, here you can see it is going to interact with the CPU, and the old PCB means after execution, you are going to maintain the record of the run already run process. Okay, so you have already execute the program, then it will go in the old PCB, and for a new process you are going the maintain the interaction with the CPU, then it will remain in the new PCB. So these are the two types of process control block. First is called the new PCB and another is called the old PCB. Means this is the already run process, and how will we maintain the record, then it will go to the old PCB. Now you can see here what's in the PCB. Okay, the PCB is a data structure. So process control block, it is nothing but a sort of data structure with many fields. Now you can check. So there are a number of fields how we are going to store a particular program, and how the process will store in the PCB. Then it is a sort of data structure at the initial state, process ID. Okay, so each and every program, now here we are going to talk about the process. Okay, under the execution or running position. So there will be a process ID. Okay, that is called the PID, the abbreviation for that, process ID. Okay, so we will maintain the we can say sort of serial number, and it is a unique number. Another is the execution state. Another you can see here execution state, and the execution state again you can see here has ready state, running state, and blocked state. So execution state again divided into three one, where you can see a ready state, running state, and the block state. Okay, and after that you can see here. Here I will explain again in the next lectures about these type of you can see states. That is the initial state. Okay, and the ready. What is the ready state, and what is the running state? What is the blocked state? With the diagram, I will elaborate it. I will explain it. Okay, in next few lectures. Now you can see another, because the PCB is a data structure with many fields. So another field is the program counter. Okay, program counter, stack pointer, registers. So far you have already studied about the program counter, stack pointer, and registers in the microprocessor paper maybe. Okay, and I don't know whether you will be able to recall that program, what is the function of the program counter, and what is the function of the stack pointer, what is the role of the different type of registers. Okay, so program counter, as you know properly, that it will increase and it will send to the next state. That is a program is equal to program plus one. That is a program counter will increase your state by just adding one. Okay, so you can reach to the another state. Similarly, stack pointer. There are other functionalities for the stack pointer and the registers. In the registers, we can temporarily store the data. Okay, so the memory management info, another field for the PCB. That is the memory management information. So it also includes the information about the memory, how we are going to store our process. Okay, what is the address of that particular place in the memory, in the whole memory. Okay, whatever we are using, that is because the process, it is under the execution or running position. So we will talk here about the RAM. Okay, random access memory, that is the temporary memory, main memory. Okay, so it will maintain all the memory management information. So it also reside in the PCB. So this is also one of the function for the, you can say, process control block. Okay. Another one field is the Unix username of owner. Now here We cannot work on the Unix machine. Okay, so there is a need arise for a particular type of username and the password also. Okay, whenever we are going, it is very safe and secure if we are going to develop some sort of username. Okay, if we want to protect our machine from other external one, other type of malware, and we want to secure our system, then we also use this field. So now this is the our primary goal uh, about the protection or to provide the security to the any type of system, whether it is any type of machine we want to protect from the other external malwares. Then this is one of the field that comes under the category of the process control block. Another one is the scheduling priority. Okay, scheduling priority to which process we are going to prioritize. Okay, so there, if there are a number of programs which are running, that is in the case of the multitasking or the multi-programming system, then we must give the priority for a particular program to which we want to run first. Okay, we want to execute one at early stage or at the initial stage. Then we also, and there are another type of the scheduling methodologies or different processes we use for the scheduling system. So we also provide this sort of priority. So this also comes under the category of the PCB, process control block, also have the information regarding to which process we are providing the priority. Another is the accounting information. Okay, accounting information, just we are going to uh, maintain the record for a particular process regarding whole process. Okay, so we can also maintain this sort of accounting information. So this all such type of fields we use related to the concerning to the process control block. So it is a sort of data structure, we can say. Okay, in the Linux, you can see here defined in task structure include like this Linux schedule.h. This is a sort of header file which we will use if we are going to maintain the records for our process. Okay, in other system we can maintain this, but in Linux we will use extra this one defined like this in task underscore struct, and within bracket you can see here include slash linux slash schedule.h. It is a sort of header file, okay, which will link all type of, you can say here, files with the Linux if we are using the another operating system here. So this is the extra the functionality which we will include during the PCB whenever we are going to maintain the record for our the old we can say the process or the new process. Then if we are working on the Linux, then we will use this extra field. Okay, now here we can see over 95 fields. Now you can see here in case of the Linux, so there are more than 95 fields we will use. Now in case of other operating system, except this Linux, now here you can see there are few fields which we will use. That is the process ID, PID, execution state, program counter, stack pointer register, memory management info, Unix username of owner, scheduling priority, accounting information. But if we will use the Linux, then if we are going to maintain the PCB, that is the data structure, then we will use over 95 fields. Here in the preceding one, there are only few fields. Now there is a type of the OS. Here you can see in case of the operating system, concurrent processes. The processes which are running together at one time, instantly, they are running all together, concurrent processes. Okay, if you are running more than one program at one time going under execution, we can say the concurrent processes. And these are the different characteristics of for the concurrent processes. Here you can see the first one is the process models and management. Okay, so in case of the concurrent processes, we will maintain the different type of process models, and we will do the different type of the management system. Okay, so if there are more than one process, we are managing more than one process, then we will use the process models. So there are number of process models which we will do. Another is the process description and the control. Okay, so if there are more than one process in case of the multiprocessor system, or in case of the several multi-programming system or the multitasking system. Here we will use the process description and control. So we will maintain our record here also, and we will provide the about the process, that is the process description and control. Another one is the task or the thread description and control. We will also maintain in case of the concurrent processes. Okay, task or thread description and control. So if there are a number of processes which are running, and under any process, okay, under any old process, there are other, you can say, different processes which are developed uh, under the old process, then we can say the thread. Okay, so here the number of tasks which are running, and under any old task, it is again classified or divided, then we can say the thread. And about that thread, under a process, there are various processes which are running, then we can say that the task or the thread description and control. So we will again maintain here the description about those threads or the task, and how will we maintain the control. Another characteristics for the concurrent processes: concurrency, that is the mutual exclusion and the synchronization. Okay, so what is the synchronization? What is the mutual exclusion? Okay, so we will tell, uh, I will do the explanation in forthcoming lectures elaborately. I will elaborate those things about the with sort of examples about mutual exclusion and the synchronization. So synchronization, just you are already aware this terminology, that is synchronization. If the frequency, if we will talk in the context of other things, then how we are going to run two different process at same frequency. Okay, so but whenever we will talk in context of here the operating system, then there is a little bit change. But you can decide in your mind that if we are going to maintain or running two process, then how we will provide the synchronization. So this is another the characteristics for the OS, and hope we will elaborate this also about the mutual exclusion and synchronization of different processes. Okay, the concurrency means deadlock and starvation. Whenever you will run a number of programs, that in case of the multi-programming or the multitasking system, I am not talking about the multi-processor system, but here I am discussing about multi-programming and multitasking. Okay, if several programs are running at a time instantly, then we can say programming system, or multitasking system if there are a number of tasks which you are going to handle at a time. Okay, then it is called the multitasking system. Then how we will provide the concurrency? Then if there is a multitasking or the multi-programming system, then the problem of the deadlock may arise. Okay, deadlock and starvation may arise. How we will see that the deadlock arise if there are number of programs or the process are running? Then suppose if we can say there are we use a number of resources, and all are occupied. Okay, have no place. Your process cannot reside or cannot go towards the CPU. Okay, or file through the file management system or the memory management system. You have already know the operating system characteristics. So if all the resources occupied by a number of processes, then the problem may arise of the deadlock. Okay, so we can see here a position uh, will come, and that very difficult to overcome. Okay, under the deadlock condition. Here you can take the example of if there is a sort of we can say the choraha. Okay, and there are number of vehicles are coming from all sides, and if there is no lighting system, or we can say uh, there is no police, then such type of condition may arise, or due to some mishappening. Suppose at the Chauraha or at one stage some sort of accident may occur, then under that mishappening, you can see such type of deadlock condition. So similarly, we can apply the same conditions here on the system. Okay, so if there are number of processes which are running, and there is no any place so that we can go back towards any resources, then such type of condition may arise. And then how will we remove such type of condition of the deadlock? Then there are again number of processes which we will use. There are methodologies, okay, and different states, and which we will discuss about the deadlock condition and how will we remove the deadlock condition, or how will we prevent the deadlock condition. Then we will we will discuss in the some few lectures, coming lectures. Okay. Yeah. Another, the characteristics of the operating system is the memory management here. The main, you can say, the property of the operating system, memory management. Here you can see real memory management. Okay, motivation for virtual memory, and paging and segmentation, page fetch, placement, and replacement. Okay. So first one is the real memory management. Real memory management means main memory. Whatever you have in your system, suppose you have the 4 GB or the 8 GB, okay. So at one place the operating system will reside. Okay. So at one place the operating system will reside, and after that, here you can see how will we use the virtual memory. Okay, and how we will manage our main memory, the first one thing. So at one place the operating system will reside, and after that the remaining memory, how will we use, okay, how will manage for the incoming task or the incoming programs. So this is again the duty or the responsibility of the operating system to manage the main memory. Here I am writing the real memory. Okay. So another is called the motivation for the virtual memory. Now here you can see how we'll proceed. That is the motivation for the virtual memory, and paging and segmentation. Here we will discuss about the paging and segmentation. And fourth one is the page fetch, placement, and replacement. So, as our system will occupy the main memory or the real memory after the installation of the operating system, then there is a game of the virtual memory will start. Okay, so then how we will transfer our first program. If the length of our program is more than sometimes the main memory, and our program length is more than the main memory, then the problem will come. Okay. So we will use the system or the process of the virtual memory. So the operating system will divide our whole program into different packets, into small packets. Okay, of few MBs. Okay, like 512 MB and again 512 MB and so on. Suppose we have the 4 GB of memory, then our program will be divided into different small packets. And how it will be managed, and it will be managed by the operating system. Okay, and now we can say suppose our program is 5 GB, and we are using the main memory of the 4 GB, even though operating system will also reside in the main memory, and after the deduction of the length of the operating system or the memory occupied by the operating system, then we can use that main memory. Okay, 4 GB means it is not 4 GB. You can use only 3 GB or 3.2 GB, like that. Suppose you are going to purchase any mobile, then suppose you have the 16 GB or 32 GB main memory or RAM. Then after installation of various softwares, you can see how much memory, main memory will be remaining. Okay, now that will call the remaining main memory, so that you can use frequently. So in that remaining main memory, you can run any software, you can make program, you can keep your own some system files or the file which which are implemented by you. So similarly, we can apply in the here also in laptop or the desktop or whatever we are using the operating system. So this is the process of the virtual memory. Our program of 5 GB will be divided into number of small packets, 512 or 256 MB like those, and those packets will run one by one, will execute one by one, and whole 5 GB program combined at the end. And we will feel that our program is running in a good manner and no any type of problem is coming. Then this concept is called the virtual memory. Okay, so this is called the virtual memory. Even though actual memory is the real memory, and suppose we have, for example, we have only the 4 GB memory, and our program or any software is 5 GB, then it is very difficult to run. Then the operating system will manage this, and this concept of dividing our program into different packets. This is called the virtual memory concept. Okay, so we will motivate for the virtual memory VM. Okay, paging and segmentation, another thing. Here we will use the paging system, and here in case of the paging system, we will divide our process or the program into different blocks. Okay, we will use the different memory blocks. Here, in case of the paging system, each memory block have same size. Okay. Again, another concept. Here, we will divide our program, but the block size of same will remain same. So that is called the paging system. Segmentation. Here, the size will be different. Okay, it will change as per need. So this is called the concept of the segmentation. Here, block size will vary in case of the segmentation. Now another operating system responsibility which is related to the memory management. It also comes page fetch, placement, replacement. Page fetch, suppose there is a sort of page, or we can say the memory block, and you want to fetch your process. You want to uh, we can say that fetch your program again for the execution after the debug. Okay, so page fetch, just you are fetching your program from the main memory, then this is called the page fetch. Placement, again you are placing. Replacement, you are changing, you are updating that. So these are different type of process which we will use, and this all record will be maintained by the operating system, and it has the relation with the memory management. So this all comes under the memory management system. Here you can see. Okay. Now I'm just taking your attendance here again. Now I will discuss about the uniprocessor scheduling here. Labels of CPU scheduling. So uniprocessor system. In case of the, if we are using only single processor, then there are a number of different labels which we will use of the CPU, and we will use the CPU scheduling. Okay, how the program will transfer from main memory to the CPU and CPU to main memory. Okay, in case of the unit processor. So if we are using a single processor, then how we will transfer that, it will call the unit processor scheduling. Okay, so there are different levels. Another, the process scheduling, how this is the another thing under the category of the uniprocessor scheduling, process scheduling. Okay, so there are again different types of scheduling methods. I will tell you again later on. External storage management. Okay, here you can see we are using the external storage beside the RAM, random access memory. Okay, So we can use either the hard disk or some other external hard disk or the pen drives, and there are other you can say a lot of external storage devices. Then how we will maintain those external storage area? Then we will use, and this is also comes under the category of the responsibility of operating system. So this is the function of the operating system. How will we maintain the memory of the RAM, that is the random access memory management, and that is called the main memory management, and also the external storage management. Okay, so under the external storage management, we can say file system or the management. After running all the programs, you can see you have to maintain on the system, that comes under the category of the file systems or file system management. Okay, there are a number of directories you will implement, you will prepare, you will make a number of directory on your system, and how you are going to create different type of directories or the file or the folders, that will be maintained by the operating system, and that comes under the category of the storage management. Okay, so just on the system, you can create any folder, you can create any file. If you are working on the Microsoft Word, then you can open, create, and all such type of activities will be done by the user. Okay, so that all comes under the category of the external storage management. Okay, and here you can see different type of directories you can maintain. File allocation, you can allocate the file. Here just you are providing the different type of space to your file. Okay, you are maintaining the record. Similarly, last one is called that also comes under the external storage management, the disk scheduling. Okay, so again there are number of types of you can say scheduling methods which we will apply to maintain this task. So here computer hardware organization, you can see here. So how we are going to connect this. Now you can see here, this is the central processing unit, and now this is the disk controller. Here you are maintaining the your hard disk. Here you can maintaining the record. Here disks, different type of external memory management you are doing here, and this is inside the hard disk controller. How it is maintaining and storing your files and folders and etc. And now this is the USB controller here. How it has the connectivity with the bus, you can see. Okay, USB controller here. And now here you can see graphics adapter. It is also has the connectivity. And here this is the monitor, printer. Here this USB controller may have the connectivity with this printer, keyboard, and here you can see the mouse. Okay, so with the help of the bus, we can connect the USB controller, and you can connect a number of input and output devices. But the major role of here, you can see this bus have the connectivity, serial bus have the connectivity with the memory. Okay, so we can emphasize more here the memory. So operating system also maintaining here the memory management, we can say. So CPU management, IO management, file management, memory management, these are the different characteristics of the operating system. So it is also called the platform operating system. It is an interface device. Here you can see it is providing the interface with the input output devices, with the memory, with the file management, with the CPU. Okay, now you can see here. Now the computer system, there are a lot of components, and how it has the connectivity you have already seen in the preceding diagram. Okay, so here we can talk about the hardware and the operating system and application programs, so different type of users. Okay, the users are those which are using that particular machine. Okay, so the hardware provides basic computing resources. And what are the different basic computing resources? CPU, that is the central processing unit, memory, IO devices, communication. Okay, so it has the connectivity with the CPU, memory, IO devices, communication. And who is providing this? The operating system is maintaining all these things. providing the connectivity with the CPU, memory, IO devices, and communication. Okay. Number two, operating system. So this comes under the category of the hardware. All these things which I told you here: CPU, memory, IO devices, communication. Then it comes under the hardware. Operating system controls and coordinates use of hardware. How will you use that particular hardware? Then it controls and coordinates use of hardware among various application program for various users. Okay. Another thing is the system and application programs. Ways in which the system resources are used to solve computing problems of the users. Okay. So just here we are going to talk about the softwares which we will use. After the operating system, you will install a number of other system softwares, or we can say the application softwares, and also a lot of device drivers, etc. firmwares also. Okay. So it will also provide the connectivity with the other type of softwares or the application software. Because after the installation of the system software OS, then again you will install other type of softwares as per your requirement or the requirement of the user. Okay, so it provides ways in which the system resources are used to solve computing problems of the users. Okay, earlier we were using the word processors and this, and nowadays we are also again using the compilers, different type of web browsers, database systems, video games. So it provides the connectivity or the interface with the other type of softwares. So this is there is a big role of the OS here. Now users, there are lot of type of, so here we can say the user, people, machines, or other computers all come under the category of the users. Okay, people may use different machines, so you can use other type of systems, computers you can use it. So these comes under the category of the computer system components. So this is called the computer system components. Okay. Now here you can see the hierarchical view of computer system. So in this diagram you can see the central part. This is called the computer. Okay, this is the central part here in the diagram. On the disk you can another, that is the part first central part, and another arrow you can see here. This one here, the operating system resides. Okay, at layer number one. This is the central part, first layer. Second layer here, the operating system. Third, you can see different type of applications here, because here you will use the hardware, and after that the operating system. Another part is the you will install different type of application software as per your requirement, and this is the area, broad area for the users. Okay, so after the hardware and installation of the operating system, and after installation of the application softwares, then the users can work in a user friendly environment. Yes. Okay, I hope this will be clear to all of you, and if any query, please welcome. I have already taken your attendance here. Now any question? So far we are going to finish this. Any query, please? Okay, thank you.